All right, so that's done. That's what we have to input for train here. So train is your training set, but without the dependent variable. Then then let's add the second argument. So the second argument is test. So you can guess what it is. It's going to be the same. Test equals test set, of course. All right, so test set. And then same as training set, we're going to remove the dependent variable because anyway, we are supposed not to know the results. We want to predict the observations of the test set. So anyway, we need to remove it. So comma to take all the lines and -3 to remove the last column. Okay, so we have our training set and our test set. And now what is the next parameter? Okay, the next parameter is CL, factor of true classifications of training set. So can you guess what it's going to be? Okay, let's see. CL equals, in your opinion, what is it going to be? Well, you know, to train a classifier, the classifier needs to have, okay, the independent variables, but it also needs to have the dependent variable because it needs to have the results to, you know, find the correlations between the informations of the independent variables and the information contained in the dependent variable. So here, since we only have the info about the independent variables, we also need to include somewhere the info of the dependent variable. And that's what we add here. That's the CL, so factor of true classifications of training set. That is the categorical dependent variable. So let's do this. So to take this vector actually, so as you can see, that's the last column of the training set. So it's going to be training set, taking all the lines, all the observations, and then the 1, 2, 3, so third index of the column purchased. So let's take that. Training set, bracket, comma, and then 3, because the column we want is indexed by 3. All right, so that's for the third argument. And then we have one more argument, which is the number of neighbors. So let's add this one. So remember in Python, we took 5 neighbors. That's actually the default parameter. So here we're going to take the same that will allow us to compare the results we obtain on Python and R. So it will be interesting. So let's take k equals 5 neighbors. All right, and now we have everything we need. We can select this, and here it is, ypred, all good. So now let's have a look at ypred. We can have a look here, ypred. I'm pressing ypred in the console and press enter to have a look at it. And here are all the predictions for the test set. So remember, the test set contains 100 observations. So here we have 100 predictions corresponding to the same observations as these guys here. So for example, let's take the first observation, the first users. So let's take the 1, 2, 3, 4, 5. So the 5 first users. These 5 first users didn't buy the SUV in reality because the purchased variable equals 0 here, and that's the truth. That's what actually happened in reality. And what does our prediction say? 1, 2, 3, 4, 5, 5, 0 here. So correct predictions for the 5 first users. Okay, perfect. Then we have 4 ones. The 6, 7, 8, and 9th users actually bought the SUV. So great for the 6th one, the 7th one, great, correct prediction. 8th one, correct prediction as well, but the classifier made a little mistake here, but that's fine. It looks like it's making some correct prediction most of the time. And we are going to check that on the confusion matrix. That will be faster. It was just to, understand, to explain what ypred was, but I think you get it. So here we just need to select this and execute. Here is CM. We can have a look at it in the console, CM. And that's the predictions. Okay, so we have 6 plus 5 incorrect predictions, 11 incorrect predictions. So that's not too bad. And now what we're most interested to see is the prediction regions, how they behave, and especially the prediction boundary to see if it's going to be a straight line or something else. And actually, you're going to see that the KNN is a nonlinear classifier, so we will get something different than what we got for logistic regression.